Hey everybody, this is Mr. Beckstrom. We're going to go through a few things from the section 3.8 on implicit differentiation. So the first thing I just wanted to touch on is the difference between implicit and explicit differentiation. So prior to this section 3.8, we've mainly done explicit differentiation. That means that we solve for the dependent variable, in this case y, in terms of the independent variable, in this case x. So it's here we're just really differentiating the right side here with respect to x and using the power rule and the constant rule there. Now this next one here, 3x plus 5y is equal to 7. This one here could be really solved through either. We could do it implicitly, that means just leave it like it is, and go through and find the derivative with respect to x of each one of these terms. And remember, when we take the derivative of a term with a y, then we either put a dy over dx there, or just a y prime if you want to shorthand that. And then this one here would be pretty hard to solve it for y. I mean, we'd have to subtract the x squared from both sides, and then we have to take the square root, and we'd be given two equations. So something like this, which is the formula for a circle, we would more than likely want to use implicit differentiation, where we go through here and do each term separately. So there's cases where we want to definitely use explicit, where we solve for the y in terms of the x's. There's some that we can really do both. You know, if we want to just do it like this, it would be implicitly, but if we wanted to solve for the y, we could pretty easily do that, and then that would make it explicit. And then we have cases where it's just really easier and sometimes necessary to do it implicitly. All right, so now on the assignment, you should be able to answer number 1, and let's go ahead and move on. Okay, now we're going to take a look at an example that's reasonably close to number 2 on the assignment, and we're given the equation 2 over 2x plus y is equal to 5x squared. So it wouldn't be too hard here to solve for y and then find the derivative explicitly. But here we are going to go ahead and use implicit differentiation. So that means we need to find the derivative with respect to x of this term, and then the derivative with respect to x of this term right here. So let's go ahead and see how we would go about doing that. All right, so for this term here, I could either use the quotient rule, or I could bring this up as a factor raised to the -1, and I could solve that using the chain rule. In this case, I'm going to go ahead and use the chain rule. I think that will be a little quicker. So I'm going to rewrite the left side of the equality as 2 times 2x plus y raised to the -1. And remember, this here is treated as 2x plus 5 to the +1. So we can take that whole factor, bring it up to the top, and change the exponent to negative. And then that's equal to 5x squared. All right, the next thing I want to do is I want to apply the chain rule here, because we have an outside function of the 2x plus y raised to the -1, and then we have an inside function of just the 2x plus y. We can use the constant multiple rule to take the 2 out and put it in at the end. So that's what I'm going to do. So I'm going to do 2, and the outside derivative of this, we pull the -1 out front, and then we get 2x plus y raised to the -2. And remember, when using the chain rule, we need to multiply by the derivative of the inside function. So this is going to be times 2 plus the derivative of y is 1. But remember, since we just took the derivative of something other than our independent variable, we have to either put dy over dx or y prime. So it's going to be 1 times y prime, which is just y prime. And then on the other side here, we're just going to apply the power rule, and x is already our independent variable, so I don't need to add anything extra there. So that's just going to be 10x. All right. So let's clean this up a little bit and see what we got. Okay. So kind of multiplying this through, that's 2 times negative 1, which is negative 2. So I'm going to have a negative 2. And I'm going to keep this term on front. So that's 2 plus y prime. And I'm going to bring this term back down to the bottom so I can make that exponent positive. So that's going to be 2x plus y quantity squared. And put that in there. And this is going to be equal to 10x. All right. The next thing I'm going to do here is try to isolate this y prime. So in order to do that, one thing I can do, I can either multiply both sides by this denominator, which will get rid of the denominator here, and then divide both sides by negative 2 in order to get this by itself. Or I can just multiply both sides by the reciprocal of negative 2 over 2x plus y quantity squared. And that's what I'm going to do here. So I'm going to multiply this side, negative 2 on the bottom, and then 2x plus y quantity squared. I'm going to do the same thing over here. So this is going to be 2x plus y quantity squared all over negative 2. And I did that because the negative 2 is going to cancel out with this negative 2. The 2x plus y quantity squared is going to cancel out with this. So on the left-hand side, now all I'm left with is 2 plus y prime. And on the right-hand side, I am left with, we can divide the 10 by negative 2. So that's going to be negative 5x times 2x plus y quantity squared. And I'm almost done. The only thing I need to really do now is just subtract 2 from both sides. And I'm going to get y prime is equal to negative 5x 2x plus y squared minus 2. All right, so this should help you in answering question number 2. Remember, there's different methods we could use to solve this. If you want to just use the quotient rule, which is the bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. You're going to end up getting the same thing. Notice we ended up getting the bottom squared here, even though we used the chain rule. That's because you're going to get a similar answer there. All right, so let's go ahead and go on to an example that's similar to number 3. Okay, so for this next example, which is similar to number 3 on the assignment, we're going to differentiate with respect to x. The function tangent of x plus sine of y is equal to y. Now, remember that the value or the placeholder that's next to the trig function is an actual angle, and this here is an actual value. So this would be a very hard equation to try to solve explicitly for y, because we really can't get y by itself, because we would somehow have to turn both of these into angles or both of them into values, and that's not very possible, especially in this class here. All right, So let's go ahead and we want to find y prime. So I'm going to go ahead and differentiate the three terms with respect to x. So the first term is tangent of x, which the derivative is secant squared of x. And I took the derivative with respect to x, so I don't need to add anything new there. Plus the derivative of sine of y is the cosine of y. But I did just take the derivative of something other than x. So I need to multiply that by a y prime. And then that's equal to the derivative of y is 1. But again, I just took the derivative of a y, so I have to put 1 times y prime, which is just y prime. So I get this. Now my next strategy is to get my terms with y prime on one side of the equality and everything else on the other side. So I have two terms here with y prime and one term without it. So the cosine of y, and I'll put the y prime up front, make it a little bit clearer, of y prime, and so that's going to stay on the left here. And then this one's going to come over, so that's going to be minus y prime is equal to, and we're going to have to subtract the secant squared of x from both sides. So that's going to be minus secant squared of x. All right, next thing we need to do is factor out the y prime from all the terms on the left. So if I factor that out, I'm going to just get a cosine of y minus 1, and that's equal to negative, let me not forget the negative, secant squared of x. And finally, I need to, oops, give me 1 second here. I will need to divide both sides by the factor here. So I'm going to get y prime is equal to negative secant squared of x all over cosine of y minus 1. And this would be the final answer. And this is y prime, or it can be written as dy over dx is equal to the negative secant squared of x over cosine of y minus 1. All right, now to the last part. This example will be similar to the fourth question on the assignment. It says find, this is the second derivative of y with respect to the second derivative of x. So it's kind of weird notation here. They put the little 2 between the d and the y on top, and the 2 to the upper right of the x on the bottom, but all it's really asking you to do is calculate the derivative twice. So let's use this example here of negative 4x plus the sine of y is equal to y. All right, well, let's find the first derivative. So we're going to go through here. So the derivative of negative 4x with respect to x is just negative 4. And then we're going to have the derivative of sine of y. That's just going to be cosine of y. And then we have to multiply that by our y prime. And then we have, that's equal to, derivative of y is 1, but we also have to multiply that by y prime. So we're going to get is equal to y prime. Now, getting everything on the same side, we're going to end up having cosine of y. Oops, this should be a y prime over there. Minus y prime. Oh, hold on 1 second here. Got that a little mixed up. All right, cosine of y times y prime, I forgot that, times y prime minus y prime is equal to positive 4. And then we factor out the y prime, and we're going to get the cosine of y minus 1 is equal to 4. And finally, we're going to get, and let me move this down a little bit here, we're going to get that y prime is equal to 4 over the cosine of y minus 1. Okay, and then we need to find the second derivative with respect to x. So what we're going to do is, again, take the derivative. Since I have already solved for this, that's on the left just going to give me the y double prime, which means the second derivative of y with respect to x. And on the right side, let's go ahead and use the, give yourself some more room. Let's go ahead and use the quotient rule for this. So this is going to be the bottom cosine of y minus 1 times the derivative of the top, which is just going to be 0, minus the top times the derivative of the bottom, which is just going to be the derivative of cosine is negative sine y. And since we just took the derivative with respect to x, we have to multiply that by y prime. And then minus 0, so it's just going to look like this. And this is all going to be over the bottom squared. So this is all going to be over cosine of y minus 1 quantity squared. So let's clean this up a little bit here. Okay, so this whole thing zeroes out. So I'm going to have a negative 4 times a negative sign. So that's going to be equal to 4 sine of y times the derivative of times y prime all over, and this is y double prime over here, all over the cosine of y minus 1 quantity squared. And now we have the second derivative in terms of both the first derivative and the y term here. Sometimes what you'll see in the book or the videos is that they will then substitute this, whatever they solved for y prime, which in this case is 4 divided by cosine of y minus 1, they'll substitute in that for the y prime. So then you just get the second derivative of y with respect to the second derivative of x, all in terms of x's and y's. All right, but for now this is good. So you should be able to do question 4. And let me know if you have any questions. Thanks.